Okay, we're going to be doing arithmetic and geometric sequences. And a sequence is basically just a list of numbers. Um, and they can have patterns to that list of how you get to the next term. To determine if it's an arithmetic sequence, an arithmetic sequence is a list of numbers where there is a common difference between each term. Or basically, you're adding the same number every time to get to the next term. And whatever number that is that you're adding is called the common difference. Okay? Okay, so for these, we're going to determine if the sequence is arithmetic or not. So to get from -3 to -8, what I'm adding is -5. And then to get from -3 to -13, I'm adding another -5. But to get from -13 to -23 is a -10. So this is not an arithmetic sequence. For this next one, to get from -8 to -2, I'm going to add a +6. To get from -2 to +4, I'm adding a +6 and adding a +6. So because I'm adding a +6 every time to get the next term, this is an arithmetic sequence. I know you're used to saying arithmetic for this word. You will more than likely hear it as arithmetic when it's being referred to as a sequence or series, which is what we're doing here. And you will also need to find the common difference, which we're going to label as D. The common difference here is that common difference between each term, which is 6. A way to figure out the common difference, if you know it's an arithmetic sequence, is take a certain term and subtract the previous term. So if I take -2 and subtract the previous term of -8, well, minus the negative becomes plus a positive, and that becomes 6. That is my common difference. And so a geometric sequence is when you're multiplying by the same number every time to get the next term. And that number that you multiply by is called the common ratio, which we're going to use as R. And so to determine whether each sequence is geometric, well, in this one, just like in arithmetic, you can take a term and subtract the previous one. To find the common ratio here, you can take a certain term and divide by the previous one. So if I do 20 divided by 8, that's going to give me my ratio between 8 and 20. And that reduces to 5/2. And if I do 50 divided by 20, now I'm taking the third term and dividing it by the second term, that reduces to 5/2. And if I take 125 divided by 50, what goes into 125 is 25, and it goes in 5 times, divided by goes into 50 twice. So the common ratio every time is 5/2. So this is a geometric sequence, and the common ratio is equal to that 5/. This one, to tell if it's a geometric sequence, I would want to do 30 divided by 19. That doesn't reduce, and it's not the same thing as 41 divided by 30, so this one is no. If you check what is the pattern here, you are adding 11 every time, so this would be an arithmetic sequence. So here to determine if the sequence is arithmetic or geometric, go ahead and pause it and try to do it on your own. There is a possibility of it being neither as well. So here are your answers. The first one is arithmetic, and that's the easiest to check. So a lot of times I check that first, find the difference between the first two, and then add that to all the other ones, and it does work to be a difference of 12. If you're checking arithmetic here, the difference between the first two is 3. If I add 3 again, it's not 9, so I know it's not arithmetic. And then if I go to check geometric, I do 5 divided by 2. And then the next one would be 9 divided by 5. They're not equivalent to each other, so it's not geometric either. So in this one, it's neither. And this one, it gets from -12 divided by 6 is -2. 24 divided by -12 is -2. negative 48 divided by 24 is negative 2. So in this one it is geometric and the common ratio is negative 2. One thing to notice here, when the common ratio is a negative, what happens is that it is alternating from positive to negative to positive to negative. Where if you remember in the one where the common difference was negative, what happened was that it was becoming a smaller and smaller number, or more negative and more negative, with the arithmetic sequence. One thing I want you to understand and to recognize is when you have an arithmetic sequence, what happens when it is graphed. And basically all it is plotting points. And so the first point, the x is 1, and the term is the y value. So you have the first term is negative 8, so I have the point 1, negative 8. The second term is negative 6, so it's the point 2, negative 6, where the x value is the term number in the sequence and the y value is what that term number is. So then I would have 3, negative 4. So what I want you to see is when we graph that, this is going to be 1, negative 8, and I have these 3 points. And I want you to notice, so an arithmetic sequence turns into what type of function? If you notice, it's going to be a straight line. And so the next, say, 4 points, you would get then negative 2. You should notice that what's happening every time is I'm adding a positive 2. Also notice that common difference was 2. What that turns into in the function is the slope. Rise 2 over 1, rise 2 over 1, rise 2 over 1 is the same as the common difference. So for a geometric sequence, I have the points 1, 10, 2, 15, and 3, 22.5. And so I have 1, 10, 2, 15, and 3, 22.5. And you can't see it as much here, but what happens is that this becomes an exponential function. And so it will start to flatten out here and rise up like that. And what happens here is your common ratio. So to find my common ratio, I'm doing 15 divided by 10, which reduces to 3 over 2. That is going to end up being the B. There's a little bit more involved with that, but we're going to get to that later. But the main thing I want you to notice is that an arithmetic sequence turns into a linear function. A geometric sequence turns into a exponential function. So we're going to talk about arithmetic sequences here. And here's a formula that has to do with arithmetic sequence. And the a sub n is what we call this. When the n is written below a little bit, it's a sub. So a sub n is equal to a sub 1 plus n minus 1 times d. And the a sub n is the nth term. The a sub 1 is the first term. The n is the term number, like the first term, seventh term would be 7, and so on. And the d is the common difference. So this says to find the 20th term of the arithmetic sequence. So what I don't know is I don't know what the 20th term is. I don't know the a sub n. I do know the a1, the first term is 3. I do know the term that I'm looking for, which is the 20th. And I do know the common difference, which is 7. I'm adding 7 every time. So I plug those in and solve for the one that's missing. It may not always be this one that is missing, but you can use this formula, plug in the things you know, and find the one you don't. So I get 3 plus 20 minus 1 times 7. 20 minus 1 is 19. Right here, you're just following your order of operations. 19 times 7 is 133. 133 plus 3 is 136. So the 20th term is 136. And how we write that is a sub 20. That means it's the 20th term. Okay, so this one is asking to write an equation for the nth term of each arithmetic sequence. And so an equation, you need to have everything simplified on the right side and just a sub n on the left side. So for this one, my A1 is negative 8, so I'm going to do negative 8. N minus 1 times the common difference. Well, the common difference is positive 2. Okay, I don't know the n because I'm trying to write the equation. You're not putting something in for n either because this equation will allow you to find any term number. So to simplify it, you're writing the equation a sub n is equal to negative 8 plus I'm distributing this 2. So 2n minus 2. Simplify the negative 8 and negative 2. I'm going to write the 2n first and then they're going to combine to be negative 10. Notice this is a linear equation. Okay, that's important because it's arithmetic, it becomes a linear equation. So for this one, the first term I don't know, okay, but I do know the sixth term here. And because I know the sixth term, I'm going to put that sixth term on the left side for a sub n. I don't know the a1, I got to find the a1 to write the equation. Because this is the sixth term, I'm going to plug 6 in for n. So if you know a certain term, what that term is goes on the left side, and the term number goes on the in the n spot. Okay, and then the common difference is negative 11. Remember, it's being multiplied though. So I have a sub 1 plus this becomes 5 times negative 11 equals 11. 11 equals a sub 1 minus 55. Add 55. All I'm doing is solving for a sub 1, and a sub 1 is equal to 66. So now I can write the equation a sub n is equal to 66 plus n minus 1 times negative 11. And when I distribute 66 minus 11n plus 11, combine those two, and I get a sub n is equal to negative 11n plus 77. Notice that the common difference here was 2. The common difference here was 11. When you write the formula or the equation for it, that becomes the slope of that linear function. So in this one, you're finding the arithmetic means in the sequence, which means you're finding the missing terms basically. What I know is I know A1 is 21, and I know 1, 2, 3, 4, 5, A sub 5 is equal to 45. So by knowing that, I can find the common difference. So I'm going to plug A sub 5 in for A sub n, which is going to be 45 equals A1 is 21 plus, and this is A sub 5 or the fifth term, so I'm going to plug 5 in for n. So n is equal to 5 there. And so now I have 45 is equal to 21 plus 4 times the common difference. Subtract 21. 24 is equal to 4 times the common difference. Divide by 4, and the common difference is 6. So then you can figure out what's in between. Add 6 every time, so that's 27. 33, 39, and if you add 6 again, it'll be 45 just to be sure, but here is the arithmetic means. So for geometric sequence, it's the formula a sub n equals a sub 1 times r raised to the n minus 1. All a1, an, and n are all the same. The r is the common ratio. Okay, and this makes an exponential equation, which is why it's r raised to the n minus 1. So find the sixth term of the geometric sequence with a1 being negative 3 and r being negative 2. So I'm trying to find a sub 6, where a1 is negative 3, the common ratio is negative 2, raised to the, and because it's the sixth term, I'm going to plug 6 in for n. So simplify that. 6 minus 1 is 5. Negative 2 to the fifth becomes negative 32 times 3 becomes positive 96. So the sixth term is going to be positive 96. So a sub n, write an equation for the nth term. I'm leaving a sub n as a sub n, and I'm leaving n as n. So my a1 is 5. My common ratio here is 2. And so that's the formula for this one. And this one I have to find the a sub 1. Okay, well I know a sub 5 is 4. So, and then that would make the n 5. So I'm going to go back to the an formula. I don't know a1. I do know the common ratio is 3. And my n is 5. So 4 minus 5 minus 1 is 4. So now I'm solving for a1. So I have 4 is equal to 3 raised to the 4th is 81. 81 times a sub 1, divide by 81, and I get a sub 1 is equal to 4 over 81. So now I can write the formula a sub n is equal to 4 over 81 times 3 raised to the n minus 1. This says to find the 3 geometric means between 3.12 and 49.92. So there's 3 geometric means between these two numbers. And so you have to notice this is the 5th term, this is the 1st term. So 3.12 times, and I need to find the common ratio, times the common ratio, which I don't know, raised to the, I do know that this is the 5th term, so I'm going to put that on the an spot and raise it to 5 minus 1 because my 5 is my term number for this 49.92. And so now I need to solve for r. So I'm going to divide by 3.12 and that becomes 16. 16 is equal to r raised to the, so this is going to be 5 minus 1 is 4. And now I'm going to take the 4th root of both sides, and r is equal to plus or minus 2. It could be positive 2, it could be negative 2. So when you're multiplying it, this could be plus or minus 6.24. This one is always going to be 12.48 as a positive, and then this one could be plus or minus 24.96. Because you took the 4th root and it's even, that's why you have the plus or minus here. So I had to find the r, and then I was able to find the geometric means. Which U.S. state has the smallest soft drinks? Minnesota.